Okay, so obviously this stuff that we've been doing the whole chapter is right triangles. So what happens is if you have a vector like that, you can figure out the directions, how to get from there to there by drawing in a right triangle. So the vector is going to be the hypotenuse. And then the two legs are the directions how to get from this point to this point. The only difference is, now remember, like, I'm just going to throw a number. Say this is 5 and that's down 3. Remember, on a right triangle, distances are never negative. But if you had to name how to get there, it would be right 5 and down 3, right? Even though when you do the distances, you don't have it as negative. But that's the directions how to get there. Okay? Magnitude, depending on the type of question, in this problem right here, the magnitude is just the length of the hypotenuse. Okay? Like I said, when we do the real world problems tomorrow, we're going to have vectors like airplanes flying and ships sailing and stuff. So the magnitude then is the speed. But in order to find the speed, you just find the length of the hypotenuse. Okay? So speed, magnitude, and the length of the hypotenuse, they're all the same. So when they tell you to find the magnitude of a vector, you draw a right triangle and you figure out how long the hypotenuse is. So the direction of a vector, we're going to do these more tomorrow, the direction, but I'll just show you. North, south, east, west, right? So obviously if something's going straight north, it's going straight up and down, straight south, straight east, straight west. But if they go northeast, that means they're going up this way, right?
Yeah.
But you can't just say northeast, because, I mean, you could go here, 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 you could go anywhere. You got to put a degree. So like say, for example, they're going 30 degrees northeast. That's 30 degrees formed with the horizon. So going out and up would be the 30 degrees.
But what if it's not exact?
Huh?
What if it's not exact?
It will be exact. You have to know how many degrees you are
But
going.
it can't be like 31 or something.
Yes, it can be. I just picked a number. It could be 2 degrees northeast. If you're going, say you're going 11 degrees southwest. So again, you're starting here. Southwest is down this way. So the angle is always formed with the horizon. That's what you got to remember. So 11 degrees means you're going out this way and then down at 11 degrees. So there's the trail they would follow at 11 degrees southwest. And then they just figure out how far they go, and that would be its magnitude. So this is the direction, and then the length that they travel, the hypotenuse, is the magnitude. Okay? Equal vectors is just what it sounds like. They're the same length. Parallel vectors is just what it sounds like. Everyone knows what parallel means, right? One intersect. Sum of the vectors is when you add two vectors together. This is the easiest part when we take our test on this. If you've got two vectors, say this is vector A and this is vector B, and they want you to find A plus B. All you do is you add this and you add that. Okay? Now, what happens when you add vectors is this. I'm going to use this graph right here. So here, I should probably have smaller numbers maybe. We'll see if this works. So, A, you got to start somewhere. It's 3, 5. That means I go right 3 and up 5. Remember X, Y? So there's vector A right there. And then B what happens is it's like an airplane flying. It flies from here to here, and then its next vector it follows, it's going to go from here to wherever. You don't go back to the starting point. So this says 5, 7, so I got to go right 5 and down 7. So then this would be vector B. Now what happens when you add the vectors together, I forgot a sign there. That just means what would have happened if they would have, instead of flying up to A and then down to B, what if they would have just went straight over to B? They went over 8 and down 2. Okay? So when you add two vectors together, what it tells you is what would have happened if you would have just went from your start point to where you ended. Okay? Does that make any sense?
Yeah.
Okay, so the where'd do this problem? Here we got P is -4, 3, and Q is 2, -1. Is the initial point and the terminal point. So it starts at P and it ends at Q. Draw PQ in a coordinate plane, then find its magnitude. So since I got negative numbers, I'd have to go like this. Oops, that's off. So -4, 3 is P. 2, -1 is Q. And then when you draw the vector, you do got to put the arrow on there to show that it starts at P and ends at Q. And so there we did that. When we actually do the test, you've got to draw it. You've got to give the component form, which means how do you get from P to Q? Remember, it's always side to side and then up and down. You can't go down first and then over. It's not slope. Slope is the only thing in math or in anything that you go up and down first. So to get from P to Q, I had to go right 1, 2, 3, 4, 5, 6, and then down 1, 2, 3, 4. So there's the directions. If you had to name it, it would be vector PQ like that. And then we got to find the magnitude. The magnitude, remember, is just the length of the hypotenuse. So when we draw in this right triangle, this is 6 and that's 4, right?
10.
Nope. So in order to find it, you use the Pythagorean theorem. 6 squared plus 4 squared, and you square root it. 7.2. So the magnitude is just the distance of the hypotenuse. Now you don't really have to draw in the right triangle. You can, because this tells you what each leg is right there. And again, if you put the negative in there, that's okay, because when you square a negative, it's going to turn positive. But you're better off just realizing it's going to be positive, so don't take the chance because your calculator might mess that up. So just put in 6 squared plus 4 squared and square it. They don't ask it yet, and we're just going to be doing this tomorrow, but I'm going to just show it to you now so you see a bunch of them. You gotta, when we do the test, you gotta name it, you gotta graph it, you gotta give the directions, you gotta find the magnitude, and you gotta find the direction. The direction, again, if this is our starting point, the direction, we're going down and to the right. Down is south, to the right is east. So the direction is southeast, but we can't just say southeast, you gotta have more specific directions. You gotta find what?
45.
It looks like it might be a 45, but it's not. Because remember, the legs would be the same if it's a 45, 45. You gotta find the angle formed with the horizon. We know it's southeast, but we gotta figure out how many degrees down do they go. So that's why it's connected with what we just did. In order to find angle P, 4 is opposite, 6 is adjacent, so which trig function do you use? Tangent. The tangent of P is opposite over adjacent. So remember, anytime you find an angle, you gotta get rid of that tangent so the p's by itself. So you do the opposite, which is tangent inverse of 4, 6. Again, you gotta make sure you're on degrees. So that turns out to be 33.7 degrees southeast. So, now again, we're not gonna do the direction today, we're just gonna do the magnitude, but I'm gonna show you how to do them so the more you see them. Now, on these vectors, it's always gonna be tangent that we're using, because we're always gonna know the two legs. Because we always know this and we always know that, right? So here we've got vector CD, they've drawn it in there, describes the velocity of a moving hot air balloon. The scale on each axis is in miles per hour and it goes by fives. So remember, you can't go up first. Vectors go sideways and then up and down. So this is by fives, 5, 10, 15, 20, 25. 5, 10, 15, 20. So to find the speed, again, speed is exactly the same thing as magnitude, which is just the length of the hypotenuse. The difference is the length here now is going to be a speed. It's going to be in miles per hour. I think it's miles per hour, right?
Yep.
Yep, miles per hour. So, to find the hypotenuse, we just use the Pythagorean theorem. 20 squared plus 25 squared, and then you square root it. Is 32.01, which would just round to 32 miles per hour.
Do you want us to always round up, or should we leave it?
Round the nearest tenth. Then part B says find the direction it's traveling relative to east. It's going up and to the right. Up is north, to the right is east. Now we got to find the angle. A lot of times people forget to find the angle, or maybe they don't know how to do it, so they just leave it blank. But remember, it's the angle formed with the horizon, so we got to find the angle of C. So the tangent of C is opposite over adjacent. So C is going to be the tangent inverse of 20 25ths. That's 38.65, which would round to 38.7 degrees northeast. The degrees tells you at what angle you're going to go. So that's what makes it specific. This just tells you in what direction you're going. Okay, so this stuff, we'll just wait, because we're going to be doing this tomorrow, actually finding the speed, which is the magnitude. Today we're just going to find, we're not going to do these today either, so wait, oh yeah, we are doing that. Yeah, we are. No, we're not. That's tomorrow also. Okay,